Welcome back to Josh Does Math. In this video, we're going to be finding the equation of the tangent to the curve that's given right here as y is equal to x to the third plus x all over x minus 1. And we're looking at the point 2, 10. So this curve, I have no idea what it's going to look like. There's the curve. And we're looking at the point 2, 10. We'll say that that is right here. So the tangent, what is the tangent? Well, we know the tangent is the point that touches once, so it's going to be like that. We know it's got to have the same slope as the curve at that point, so I'm going to take the derivative of the curve right here to figure out what the rate of change is of the curve at this point. In other words, you could say the instantaneous slope of the curve, and that's going to be the same slope as the tangent, so that'll be our starting point. So I'm taking the derivative of y with respect to x, so it's going to be d x to the third plus x dx minus 1. I'm sorry. We're taking the derivative of the whole thing with respect to x. So this is going to be a quotient rule problem. So we're using the quotient rule right here. Quotient rule says derivative of the top times bottom minus derivative of the bottom times top all over bottom squared. So that's what I'm using right here. Derivative of the top is going to be 3x squared plus 1. I just used the power rule twice. Bottom, x minus 1, minus derivative of the bottom, it's just 1, times top, x to the third plus x. And this is all over bottom squared, x minus 1 squared. All right, I'll just simplify this down a little bit. So I'll do FOIL right here in the top. So I get 3x to the third minus 3x squared plus x minus 1 minus x to the third minus x. I distributed that negative 1 in all over x minus 1 to the third to the second power. And we can simplify that numerator a little bit further just by combining some terms together. So we can see that x and negative x are going to cancel. And we can combine these third power x terms. So that's going to be 2x to the third minus 3x squared minus 1 all over x minus 1 squared. So this is my derivative formula right here. And I want to find the derivative, not just some general formula like this. I want to find the derivative at 2, 10. In other words, when x is 2. So when x is 2, what is our slope? So I'm plugging in x equals 2 for every x right here. So this is going to be 2 times 8, that's 16, minus 3 times 2 squared, so that's minus 12, minus 1, all over 2 minus 1 is 1 squared. That's going to be 1 in the denominator, so I don't even need a fraction anymore. And I can simplify this. That's going to be 4 minus 1, 3. So I know that the slope at x equals 2 is 3. So that doesn't give me the equation of the tangent, though. For the equation of the tangent, I need a point and a slope, and I can set up point-slope form. Well, it turns out I do know a point. It's right here, 2, 10. I'm given that point is the point we're looking at. And I know the slope. Slope is right here. It's 3. So I'm going to set up point-slope form now for my tangent line. Y minus 10 is equal to m x minus 2. And m is 3, so I'm just going to plug that in. 3 times x minus 2, and I'll distribute the 3 right now. So that's going to be 3x minus 6. And then I'll add 10 to each side. And I end up with, for my tangent line, y is equal to 3x plus 4. That's the equation that I get for my tangent line. And as you can see, all I did was use the quotient rule to take the derivative here, plug in a couple of numbers. That's it. Thanks for watching.